All right, let's get started.
Okay. Where is everyone?
Today is chapter 34, and we actually have 2 days dedicated to this chapter. The questions that I had submitted for chapter 34 so far were questions on number 67, number 79, number 101. I'm going to do my best talking today. I am getting over a cold.
You said physicists don't get sick.
Oh.
Did I?
Yeah.
Okay, then I lied.
You got intestinal bacteria.
You know why? You know why I got sick? I'm working with a bunch of biologists. If I was working in physics, I'd never be sick. Again, I'll do my best. If I break into a coughing spell, just let me cough up my lung, and then I'll start over again.
And then we'll dig you because we're going to be doctors.
So on number 67, we have an object that's located 15 centimeters from a concave lens of focal length negative 20 centimeters. What is the image distance? Is the image real or virtual? Is it upright or inverted? Is it larger or smaller than the object? And what is the magnification? So there's a ton of questions there. And they didn't give us a ton of information. They told us the distance of the object. The object distance they gave us was 15 centimeters. What letter do I use to represent object distance according to your book?
Isn't it F?
They use S. I like to use DO, distance of the object. That makes sense to me. You can use whatever you want. 15 centimeters. And then they give us a focal length of negative 20 centimeters. Why is the focal length negative?
Because it's on the side that you don't want it.
Nope.
You don't expect it.
Because it's a concave lens. If it's a concave lens, it's a negative focal length. Convex lens is a positive focal length. Okay, so it describes the type of lens that you have. Okay, so first I'm asked, what is the image distance? How can I find?
thought that was the negative and positive was if you were in front or behind the lens.
That's for the object distance or image distance, not for the focal length.
Okay.
Okay. Because the lens has two focal lengths. How do I find the image distance here?
Isn't it 1 over S
1 over S
minus 1 over S1?
plus 1 over S prime equals 1 over F. What's the name of this equation? Pretty important equation for lenses. So important we call it the lens equation.
I was going to say that.
Pretty easy, not a trick question. So which one of these variables is the image distance?
S.
S is the object distance.
Then it's S prime.
S prime is the image distance, so I need to solve this for S prime. So I can do 1 over S prime equals 1 over F minus 1 over S. Okay. So we can do 1 over S prime equals 1 over the focal length. What's the focal length? Negative 20. Negative 20 minus 1 over S. What's S? 15. People are whispering. So 1 over S prime is equal to negative 0.12. Is that the right answer? Is that my image distance? No. How do I get my image distance?
Take the reciprocal.
Take the reciprocal. I flip it. So I can multiply S prime over to the other side and then divide both sides by 0.12. So take the reciprocal of this to get S prime is negative 8.57 centimeters. That is my image distance. Next, they ask us, is this real or virtual? This image real or virtual?
Isn't it virtual because it's negative?
Yep. If S prime is negative, then you're virtual. So this is a virtual object, virtual image. Is the image upright or inverted, larger or smaller than the object, and what is the magnification? So to answer all of those questions, we actually just need to calculate the magnification. So I'm going to jump ahead to part E to find the magnification. How do I find magnification?
Magnification equation.
The magnification equation, which is negative S prime divided by S. So magnification is negative S prime, and S prime is negative 8.57, divided by S, which was 15. So the magnification that I have here is 0.57. And I can use this to answer part C and part D. Part C is the image upright or inverted? How can I tell based on the magnification if it's upright or inverted? What was that, Quinn? The sign. What is the sign of the magnification? Positive. So does positive mean upright or inverted? What do you think?
Upright.
Upright. So this is upright. And then part D is the object larger, or is the image larger or smaller than the object?
Can you ask the question?
Is the image larger or smaller than the object? So I can look at the magnification. What is the magnification? 0.57, about 1/2. So the image is going to be about half the size of the object. Yeah? So is it larger or smaller? Smaller. Basically, if the magnification is less than 1, then you're going to get something that's smaller. If the magnification is greater than 1, you got something that's bigger. So these kinds of lens equation problems, these are just puzzles. Just kind of got to know what different signs mean, and you can answer a ton just from a couple different equations. Okay. Yes, babe.
For the magnitude equation, we always multiply by
Magnification is always negative S prime over S. So the magnification might be negative if your S prime is positive. So here the negatives canceled out. That won't always happen. Yeah.
Is there any other information you asked us for this all this stuff besides what you've already shown, like for our test question?
Sure. I could ask about. I could give you another piece of information. I could give you the height of the image or the height of the object, and ask you about the other.
Okay.
I could flip things around, and instead of giving you the image distance, I could give you the, or instead of giving you the object distance, I could give you the image distance. I could give you image distance and object distance and make you calculate the focal length. Or I could add in another element. I could do a lens and a mirror at the same time. Any other questions on this one? In that case, let's do that. Let's do lens and a mirror at the same time. That's going to be question number, I think. What was the other one that was asked? 79. It's the first time I've ever taught while taking Mucinex. It's interesting.
Oh, I rode my bike from Alexandria this year on Lucid Next Did you ride your bike this morning?
No, I drove.
Oh, good.
I drove to. It took me 2 hours to drive here. It takes me an hour to bike. So angry.
Biking for the win.
All right, number 79. We have a light bulb that is 15 centimeters in front of a convex mirror of radius of curvature 10 centimeters, and then a convex lens of focal length 25 centimeters is 5 centimeters beyond the light bulb. See the figure below. Where do you see the image of the light bulb if you look through the convex lens at the mirror? So this one's a little bit weird. Did you say they're all a little bit weird?
Yes.
You're weird.
I am.
Creepy biologists. Here's our light bulb, and they give us some information. They tell us the light bulb is 15 centimeters in front of a convex mirror. So here's my mirror. Here's my light bulb, 15 centimeters away. They also tell us the convex lens of focal length 25 centimeters is 5 centimeters beyond the light bulb. So the distance from this light bulb to this lens is 5 centimeters. I'm given the radius of curvature of this mirror is 10 centimeters. And the focal length of this lens is 25 centimeters. Now, why is the focal length of the lens positive? The last problem was negative. Nope, it's because of the type of lens that it is.
Oh my gosh.
This lens is convex, so the focal length of a convex lens is always positive. If it were concave, the lens would have a negative focal length. Okay. Excuse me, sorry. And sorry to YouTube. So we need to know where we see the image of the light bulb if you look through the convex lens at the mirror. So I'm going to look through this lens, and I'm not going to look directly at the light bulb, I'm going to look at the mirror. So the lens is going to focus on whatever the mirror sees. So first what I need to do is I need to see where the light bulb is in the mirror, find that image, and then that image will become the object for the lens. Okay? All right. So to do that, I first need to use the mirror equation and form the image from the mirror, and then use that for the object for the lens. Yep. First, I need to use the mirror equation. What's the mirror equation?
Isn't it S negative S prime over S?
1 over S plus 1 over S prime equals 1 over F.
Yeah, that's what I meant.
Mirror equation is the same as the lens equation. Now, did they give us the focal length of this mirror? Yes? Where is it? I don't see the focal length of the mirror.
They only gave us the
But I'm on Mucinex, so what did they give us for the mirror?
radius.
The radius of curvature. All they gave us was R. Do I know how R and F are related? Yes. How are they related?
F is 1/2 R.
F is equal to 1/2 of R. The other question is this F positive or negative? A convex mirror and convex mirrors have negative focal lengths. So the focal length for this is negative. Convex mirrors are negative. Concave mirrors are positive.
You said the opposite.
Convex lenses are
You said
positive.
opposite. Wait. Can you repeat that? I'm sorry. You said opposite.
Yes. So a mirror has opposite signs to a lens. So a convex lens has a positive focal length. A convex mirror has a negative focal length. Okay? So we need to have a negative focal length. Focal length, F, is then going to be negative 1/2 times the radius of curvature. What is the radius of curvature? 10. So the focal length of this is negative 5. Okay? Okay. All these things are tough to keep in mind, tough to keep in track. So how are you going to keep all these signs?
Our cheat sheet.
Use your cheat sheet. Okay? Put them in your cheat sheet. There is actually a guide in the book that tells you when the signs are positive and negative. Put that guide on your cheat sheet and practice using it. Okay? The positive and negative signs, that's what will mess you up on these problems. Okay? But if you practice, you should be in good shape. So now I can find S prime. So I need 1 over S prime equals 1 over F minus 1 over S. 1 over S prime for the mirror is 1 over negative 5. So that was the focal length. Minus 1 over S. What's S? How far is my light bulb from the mirror?
20.
Where's the light bulb? To my mirror is 15. So my object is 15 centimeters away, so I plug in my 15. So 1 over S prime is going to give me a negative 0.26 with the 6 repeating. And then I need to take the reciprocal of that to get negative 3.75. And what I like about this problem is you have to know what that negative means. What does the negative mean for image distance for a mirror? So the way I think about this, it works for me. If I'm looking in a mirror, I expect my image to be formed on the same side of the mirror, right? It reflects back at me. If I'm getting a negative image distance, that means that my image is forming on the side of the mirror that I don't expect it to be on. So my image is forming on the opposite side of the mirror. I'm behind the mirror. Yep. So my image is going to form over here. So I can draw that in. My image is negative 3.75 centimeters back.
And how do you know it forms there?
I got the image distance. It's negative 3.75. Since it's negative, a negative image distance means I form behind a mirror.
Okay.
That's opposite for lenses. A negative image distance means I form in the front of the lens. The sign conventions, that's what will really screw you up in these. So now I need to take all of this, let's shrink it down a little bit, and we need to actually find the distance that I get for the lens. So now I'm going to look through this lens, and I'm not going to see the light bulb, I'm going to see the image from the mirror. So I need the object distance from the lens. How far is that image from the lens? I get 5 centimeters plus the 15 plus the 3.75. So I get 23.75. What's the focal length of my lens? 25. Positive or negative? It's a convex lens. Convex lenses have positive focal lengths. Yep. So then I can find 1 over s prime plus 1 over s equals 1 over f. Solve this for s prime. 1 over s prime equals 1 over f minus 1 over s. 1 over s prime is going to be 1 over 25 minus 1 over 23.75. I get 1 over s prime is negative 0.0021. So s prime, when I take the reciprocal of that, is ridiculously big, is negative 475 centimeters. So where is that going to be? Where is that image? This is S prime. My eyeball's over here. I'm looking through this lens. Where do I expect an image from a lens to form? On the opposite side or on the same side?
The opposite side.
I expect a lens to form on the opposite side. If I got a negative number, what does that mean?
Same side?
It's on the same side. It's on the same side of where I'm looking. So it's over. Okay. Any questions? This is a very strange problem. Question?
What does that say? Negative 0.0021.
0021. That's a 2. And a 1. Not a hook and an L. Drawing hooks, playing too much Sea of Thieves.
Oh my gosh. Ew.
Anybody else playing Sea of Thieves?
I've watched it.
It's so boring, but I keep playing.
Ugh.
Any other questions on number 79? What do you think is more likely to appear on an exam? Something like 79 or like 67? You hope 67, but 79 is much more likely. Okay? Other things I could ask you to do. I could ask you to draw it to scale. Could I ask you to draw this to scale?
No,
No? Why not?
because it's 410.
Because that's 475 centimeters. That's a bit too large, right?
You have to go some little on paper.
Yeah. Make you improvise. Okay. No other questions on this one? Alrighty. Then let's do the last one that I was asked about. Let's do problem number 101. Problem 101. We have a prism that has 3 equal angles of 60 degrees. The prism is made of flint glass of index of refraction 1.66. At what angle should a ray of light enter this prism so it is refracted symmetrically? So this is problem 101. A prism. I want light to come in, and I want to refract, and I want all of this to be symmetrical. So that means that I basically want the light on the inside of this to go through completely parallel to the bottom of it. If it's at any kind of angle, it's not going to be symmetric. It's not going to be the same thing happening on the left as the right. It has to go straight through. Yeah? Does that make sense? When I first read this problem, I was like, what the? I had no idea how to do it. Then to think about it, and I think that makes sense. Yeah? I want the same thing on the left and right. So it has to go straight through. Okay? I want to draw a couple perpendicular lines. So those lines give me angles. So I have a light ray that comes in at some angle. It's going to refract at some angle, theta 2. Then over here I'm going to have the same theta 2, and I should have the same theta 1. I'm refracting inside of a prism. What kind of equation might I use for this? What equations do I know for refraction?
Oh, isn't that the
There's some kind of law?
theta 1 equals theta 3?
No. V equals C over N. Okay. Any other laws that have to do with refraction? There is one. It's called the law of refraction. N1 sine theta 1 equals N2 sine theta 2. I want to know what angle I have to enter at this thing with. So what angle would that be in this picture? What's the angle that I'm entering at? Theta 1. So I need to solve for theta 1. So I'm going to do sine of theta 1 equals N2 times sine of theta 2 divided by N1. And then I take the inverse sine of both sides, and I get theta 1. Inverse sine N2 sine theta 2 over N1. All right, let's see what I can plug in. Hopefully I know everything. I'm a physicist, so of course I know everything. Except how to get healthy. So we're going from air. What's the index of refraction of air? 1. And I'm going into flint glass. What's the index of refraction of flint glass? More than 1. 1.66. How do I know that? I'm a physicist. I know everything. And they gave it to you in the problem. So I can plug in N2 is 1.66. Sine of theta 2 over N1. Do I know what theta 2 is? Do I know theta 2? Do I know that angle? I do. I have to go back to high school, and I have to do some geometry. So they told us this angle is 60 degrees. They told us actually that all these angles are 60 degrees. So if all 3 of those angles are 60 degrees, what are these 2 angles? Those are also 60 degrees, right? Similar triangles. So those are both 60 degrees. Wonderful. Is that the angle I want? Just plug in 60 degrees? Nope, that'd be too easy. But 60, which I've conveniently written as go, and theta 2, they add up to equal something. What's that whole angle? That's a right angle. That whole thing's a right angle. So 60 plus theta 2 equals 90. So theta 2 has to be 30. $30. Thing I hated about physics. God, I remember high school again. So theta 1 equals inverse sine. Well, I assume it was high school for all of you. It was elementary school for me. Just kidding. I am joking. That was 9th grade. plug and chug all this in, you get theta equals 56 degrees. And there's your number 101. Questions? What could I change about this problem? I can give you a different material. That would change the index of refraction and the 1.66. I could also change the triangle. Instead of doing an equilateral triangle, right, that's what's 60, 60, 60, I could give you an isosceles triangle. In an isosceles triangle, I could give you this angle. Let me say that angle is, oh, I don't know, 80. If that angle's 80, what are these two angles? In an isosceles triangle, these two angles would have to be equal to each other. So what would they have to add up to? How many degrees in a triangle? 180. So each of those would have to be 50. Is that testing physics? Is that testing high school geometry?
Yes.
Do I want to test you on high school geometry?
Yeah.
No.
Absolutely, because I'm cruel. No, I won't test you on high school geometry. Okay. Any other questions on this one?